Hello ladies and gentlemen. Today we have Pre-Calc lesson 36, angles greater than 360, sums of trig functions, and boat in the river problems. Now a lot of this is review. Some of it is new, but most of it is review. So let's talk about angles greater than 360. We will look at the angles in their polar coordinates, the initial side on the x-axis, meaning that we always start over here at 0 and we go around. Or for this is positive, right? Positive we go counterclockwise, a nice little reminder. Negative we go clockwise. Okay. Now we have what's called coterminal angles. This is what we will use when we have angles greater than 360. And there's two types. The first type is that they are on the same terminal side. So for example, this is 45 degrees, and it is also negative 315 if we go all the way around in the negative. Okay, those have the same terminal side. Now we could also have angles that differ by integer multiples of 360. So this angle here is 20 and 380. Okay, that is how we will be able to determine each of those different angles. And we're going to use all of this in our sums of trig functions. We will have trig functions now that will have greater angles, or angles we don't know as well, and we will use that to determine our sums of trig functions. Always, 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 you need to draw a diagram. Okay, that is required. That is part of what I'm grading you on. And then you need to determine the related angle. So let's do some examples. If you need to pause, please do. I'm going a little quickly through this. So our first example is if we have the cosine of 135 plus the tangent of 330. So I'm going to draw 135. 135, I start at 0 and I go over. Puts me here. Now I always want to find the angle inside of this triangle. If this is 180 degrees, this is 135. The difference here is 45. Meaning I have my 45, 45, 90 triangle. So the cosine of 135 is the same thing as the cosine of 45. And then we think about all students take calculus. Cosine in the second quadrant is negative. Let's look at 330. 330 puts us down here. This is 360, 270. And again, I need to find the angle in between 330 and 360, and it gives me 30, leaving me with my 30, 60, 90 triangle. Okay, so the tangent of 330 is the same as the tangent of 30, and again, all students take calculus. Tangent is negative in the fourth quadrant. So we know that the cosine of 45 is root 2 over 2 with our negative, and the tangent of 30 we know is opposite over adjacent, which is 1 over root 3, or just root 3 over 3. Right? I'll show that little work if you didn't see what I did. We have 1 over root 3. We rationalize the denominator, leaving me with root 3 over 3. Now I want to combine these into one fraction, so I'll have negative 3 root 2 minus 2 root 3 all over 6. Okay, that is my first problem. Okay, let's do this next one, cosine of negative 60. So negative 60 is down here. I have my 30, 60, 90 triangle, root 3, 1, and 2. So the cosine of negative 60 is the same thing as the cosine of 60, right? Because cosine is positive in the fourth quadrant. Okay, and we know that the cosine of 60 is 1/2. Now let's look at 210. We know that this is 180, this is 270, so 210 puts us here. This is 210. Now, we've gone 210 minus 180. We've gone 30 degrees past 210, leaving me with, again, my 30, 60, 90 triangle. So the cosine of 210 is the same thing as the cosine of 30, and it's negative because cosine is negative in the third quadrant, which we know that the cosine of 30 is root 3 over 2. So I now have 1/2 minus root 3 over 2, which gives me 1 minus root 3 all over 2. Let's do one more. The cosine of 570 plus the sine of negative 765. So in this case, 570, we've gone all the way past 360, and then we all the way go over here past 180. We go 30 degrees past 180. 570 minus 360 is 210. So the cosine of 570 is really the same thing as the cosine of 210, which is the same thing as the cosine of 30, and it's negative because we're in the third quadrant. That is our coterminal angle. And we know we have root 3, 1, and 2. Negative cosine of 30 is negative root 3 over 2. Let's look at the sine of negative 765. Negative 765, we go all the way around. We go all the way around again. And then we go past just a little bit. The little bit we go past is 45, right? 765 minus 360 minus 360 again leaves me with 45. You could also do 765 minus 720. Okay, so the sine of negative 765, is really the same as the sine of negative 45, which is the sine of 45, and we know that it's negative because sine is negative in the fourth quadrant, and the sine of 45 degrees is root 2 over 2. So when we add these, we have negative root 3 over 2 minus root 2 over 2, and that leaves with negative root 3 minus root 2 all over 2. Okay? All right, let's move on to our next one, our next section, boat in the river problems. Now this is a review of last year. Okay, we definitely did this. And we know that, okay, if you are going with the current or downstream with the wind, right, our rate is the speed of the boat plus the speed of the water, the speed of the plane plus the speed of the wind, the speed of the bike plus the speed of the wind, right? Those are all the different kinds that we had. In our distance problem, we have rate times time of downstream equals distance of downstream. For against the current or upstream or against the wind, right, our rate is B minus W. Okay, now I like to have you guys draw a chart. That is what I'm going to show you next. I think it's the easiest way. So in this example, the plane can fly 5 times the speed of the wind. So we're going to have with the wind and against the wind, distance, rate, time. Okay, the plane, so the speed of the plane can fly at 5 times the speed of the wind. So I know that with the wind, my rate is P plus W, and against the wind, my rate is P minus W. We flew 360 miles downwind. Downwind is with the wind. It's like going downstream. And it was in a half an hour more than it took to go 132 miles upwind. So if my time upwind is T, this is going to be T plus 1/2 my time with the wind. Now I set up my equations. We have 396 equals my rate. Now I know that P equals 5W, so I have 5W plus W, which is 6W, times T plus 1/2. Okay, and my other one I have 132 is 5W minus W, which is 4WT. I'm going to solve this equation for WT. WT, I know I can use to plug in to my other equation. So I will do 132 divided by 4, which gives me WT is 33. Now let's look at this equation. We're going to distribute. So 396 is 6WT plus 6 times a half is 3W. WT is 33, so I'm going to plug that in here. So I'll have 396 equals 6 times 33 plus 3W. So then I can do 396 minus 6 times 33. 198 equals 3W. And that gives me W is 66 miles per hour. Do not forget your units. Units are very, very, very important. It asks me for the speed of the wind and the speed of the plane. So the speed of the plane is 5 times the speed of the wind, which gives me 330 miles per hour. I would like you guys to draw this chart. I think it is very, very, very helpful, especially because you guys have still been getting these kind of problems wrong. So it's a really good place to start. Well, that is all for today's lesson. I hope you guys have a good rest of